Hi everybody, welcome back to this channel. Thank you very much for joining me once again. If you're new to the channel, guys, please make sure that you're subscribed. Just turn on that notification bell so that you can be notified every time when we drop a new session. Okay, so we are still continuing revising your 2024 pre-trial exam from your Mpumalanga province, and we're gonna look at this question on maths paper 2 on trigonometry. Without wasting any time, let's get into it. Okay, quite interesting and a bit challenging trick question, right? Let's go and look at it. 5.2, it says evaluate without using a calculator. We are given sine 35 cos 35 divided by tan 225 cos 200, right? So every time in trig, when they tell you without using a calculator, right? They want you to think about the rules that you have learned and the incorporation mostly of the special angles, right? Because that's the way you can reduce this and simplify it, and in such a way that you can get an answer without using a calculator. Think about the rules and also how to reduce, trig ratios to their simplest form and all that, right? So that's the idea really. So with this question, if you check on top on the numerator, you have sine 35 cos 35, right? You can see that this is coming from the rule of the double angle, right? For example, if you have sine 2x is the same as 2 sine x cos x, right? You can see sine x cos x, similar to that expression. If you divide by 2 both sides, you have 1 over 2 sine 2x. The 2 will go away. It's equals to sine x cos x, right? That is when you divide by that 2 both sides. Okay, so you can see that sine x cos x is related to the double angle of sine there. It's just that it's half sine 2x, right? So using the similar idea, we can simplify that to say, okay, this will be half the sine of 2 times the double of that angle, 2 times 35. Okay, so that's the idea there. Then we can go to the denominator, right? If you check on the Cartesian plane, the angle 225 is between 180 and what? And 270 degrees, which is defined as 180 plus theta. Okay, that quadrant is defined like that. So obviously 225 will be the same as what? We can rewrite it as 180 degrees plus how much? To get how much, you just say 225 minus 180, you get 45. So if we add 45 on 180, you get 225, right? So cos 200, right? With cos 200, also 200 is between 180 and 270, which is defined as 180 plus theta, so it will be 180 plus a certain angle. Obviously this will be what? Will be 20 degrees, right? So that it will be 200. Okay, so we can simplify that quickly. We have 1 over 2. If you say 2 times 35, that will give you what? 70 degrees, right? Divided by tan 180 plus 45. 180 is on the third quadrant. Tan is positive. We can reduce it to what? To 45, right? Tan 45. Then this one, 180 plus, it's where tan belongs. It means cos will be negative. When you reduce it to be negative what? Negative cos 20 degrees. All right. So if you simplify this, you have 1 over 2 sine 70 degrees. 45 is a special angle, right? So tan 45 will be 1 divided by 1, which is just 1, right? Times minus cos 20 will remain minus cos 20 degrees there. Okay, let me just use a black color. I think the red is perhaps not that visible. So if we simplify this, you can see that at this point there's some quite relation between these two. Can you see? If you find that you have sine and cos and they are dividing each other, and the angle here, when you add them, they give you 90 degrees. They are basically the same, so you can just simply cancel them out, right? Very important, let me repeat that. If you find you have sine of an angle, let's say 10, dividing by cos of maybe 80, right? It's sine over cos, and this one is 10, this one is 80. When you say 10 plus 80 and it gives you 90, basically the two are the same. You can just cancel them and that will give you 1, right? But for the sake of this question, we have to show them. So what we can do, we can go to the quadrant when we have 70 is 0 degrees and 90 is the first quadrant, defined by 90 degrees minus theta, right? So obviously I can rewrite sine 70 into sine 90 degrees minus 20 degrees, right? Because 90 minus 20 will give you 70, right? Divided by minus cos 20. Okay, so this is on the first quadrant. So sine will change, 90 will change sine from being sine into cos, because it's a co-function, right? When you simplify this, it's on the first quadrant, all of them are positive, so but sine will change into what? Into cos 20, because we are using a co-function 90 there. Okay, can you see now? These two will just cancel out each other. So someone would have seen it at this point to say, no, this is 70, this is 20, and when I add them, they give me 90. These two will just cancel out. Okay, so we have finally the answer will be negative 1 over 2. All right, let's go to 5.3. All right, 5.3, quite a very interesting question, a bit challenging, but let's go and exploit. We are given that 1 minus tan A over 1 plus tan A is equals to cos 2A divided by 1 plus sine 2A. And we are being asked to prove this identity. Okay, let us go and prove it. I'm going to use the right hand side to prove, right? For me, it has quite rules that we can use to be able to reverse back to the other one, right? So because I can see some double angle of cos, double angle of sine, so for me that's quite usable. So I'm just going to choose the right hand side, which is cos 2a divided by 1 plus sine 2a, and we're going to try to simplify it into the other trig ratio, right, into this. Okay, so cos 2a can be changed into three things. Can be changed into cos squared a minus sine squared a. It can be changed into 2 cos squared a minus 1. It can be changed into 1 minus 2 sine squared a. Okay, so we can change it into all those three things. I'm just going to choose the first one because I can be able to factorize it again, right? So this is cos squared a minus sine squared a. I'm changing this into that, right? Divided by 1 plus sine 2a, the same as 2 sine a cos a. All right, so you know that on top we can factorize, right? You have cos a, sine a, what? Sine a, you have plus and minus, right? Obviously it will be first times first, cos squared a, last times last, minus sine squared a. All right, so if you check here on the denominator, can we factorize as we did like that? Not yet, but rather if we change this 1 into sine squared a plus cos squared a, we can start to see something there, right? So if I write it properly, if I put this in the middle, right, so I'll have something like 2 sine a cos a plus cos squared a. I didn't change anything, I'm just putting that one in the middle. We still have sine squared a plus cos squared a, which gives us that 1, right? So I'm writing it in a way that you can see that it's actually factorizable, right? So I'm just gonna factorize that. Let me copy my numerator as it is, divided by, you can see this actually is the same like when you have x squared plus 2xy plus y squared. Can you see this expression here in the denominator is the same as something like this, and this is factorized to say x plus y, because x times x, x squared, x times y, xy, x times y, xy, xy plus xy, 2xy, y times y squared. Can you see? So that's the idea there, right? It's a bit challenging, but yeah. So this will be sine A plus cos A. This is sine A plus what? Plus cos A. All right. So sine A plus cos A, sine A cos A will cancel, right? We are now left with, I'm just going to write it here, we are left with cos A minus sine A, which is being divided by what? By sine A plus what? Plus cos A. Guys, we are at this point now. How can we reverse it to tan? For me to get tan A there, right? For me to get it back there, let's check something. Let me show you something very quickly. On top, on cos A minus sine A, if I come and divide here by cos A, I'll get 1. If I come here and divide by the same cos A, I'll get what? I'll get tan A. Can you see? So that is the manipulation that we're gonna do. So basically what we can do is, okay, I just simply need to divide by cos A. All right. So to do so, I'm just gonna multiply by 1 over what? 1 over cos A. To maintain it, I do it also on this other one here. All right. So what you do on top, you do on bottom. It's like you are dividing by, you are multiplying by 1. You are not changing anything. Can you see? So this 1 over cos A will multiply there. Then we'll have what? Cos A divided by what? Sorry, cos A minus sine A divided by what? By cos A. It was a bit challenging, guys, right? Divided by, you can do it here. You multiply this with this, this with that. Okay. So it will be sine A divided by cos A plus cos A divided by what? By cos A. We can finally get the answer. This will cancel this. It will be 1. So now I'm writing my answer, right? It will be 1 minus sine A over cos A, tan A. Can you see? We are getting somewhere. We come here, sine A over cos A, tan A, cos A times cos A plus 1. Can you see this expression now? It's now the same as that one. We can conclude right hand side is the same as what? As left hand side. Both of them are equals to 1 minus tan A, 1 plus tan A. I hope you find that helpful. Let's go to 5.3.2. 5.3.2, okay, it says hence, without using a calculator, determine the value of this. Guys, these questions are connected. When they say hence, they are saying the answer to the previous question should enable you, give you a hint to solve this one, right? You shouldn't even stress. Hence is 3 marks, right? So maybe let me use a green color for this. So we already know that this expression like this, when it's tan, is equals to cos 2a over 1 plus sine 2a. They just doubled the angle. We're going to do the same. We'll say this is the same as cos 2 times 22,5 in our case here, right? Divided by 1 plus sine 2 times 22,5, because those ones are the same like that. Okay, so this will give you cos 45 degrees divided by 1 plus what? Sine 45 degrees. Okay, you have your special angles. Now it's now very simple, because we know that cos 45 is the same as what? Is the same as 1. Let me use a red color here. This will be the same as 1 over root of 2, right? Because they say without using a calculator, then this is the same 1 plus 1 over root 2. Can you see? We can simply leave it there, or we can simplify if we want, right? When you simplify it, you'll get this one will be divided by 1, you know, and this one will be divided by that. Can you see? So we can separate in that way. Not necessarily I'm making a mistake here. We can't do that. We can't separate in that. That's just a misconception. What we can do, we can simplify here and then simplify there, or we can just leave it at this point, because they just determine the value. So that's the value without using a calculator. Okay, it's 3 marks by the way. They just wanted you to understand this conversion here, that you can use the previous to get to the next one. Okay, I hope you find it helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.